Okay, in this clip I'm going to review the weathering processes that we discussed in the learning module on weathering in sedimentary rocks. And we said that we could subdivide all the weathering processes into two categories, physical weathering and chemical weathering. And then we only went over a few of the common physical and chemical weathering processes. So we're going to list them here. And for each of the weathering processes, you should know how the process works, what it affects, and what's produced as a result of the process. All right, so we're going to start with the physical weathering. And the first one that was discussed in the learning module was freeze-thaw. And that's simply when water gets into cracks in rocks and the temperature goes below freezing for a long period of time. The water in the crack will freeze, and the expansion of the ice in the crack as the ice forms, that will help to make the crack bigger and bigger, and eventually could break off pieces of rock. So that'll result in the accumulation of sort of angular blocks of rock at the base of a cliff or along a slope that's known as talus. Okay, so like the talus material. That will form as a result of freeze-thaw processes. Okay, so that's a process that will go on in seasonally cold climates. And then the second one we talked about was pressure release or unloading. Two terms for the same thing. Pressure release or unloading. And the way that works is when the rocks are underground down in the crust, and most rocks do form within the crust, they're under pressure, the lithostatic pressure that comes from the weight of overlying rock. So when later the rocks are exposed at the surface, they're under the much lower atmospheric pressure, and the rocks will expand slightly because the pressure's been reduced. When the rocks are under pressure down in the crust, they compress a little bit, and when they're exposed at the surface and the pressure is much lower, they expand a little bit. And so that forms fractures or joints in the rock. And I think I showed some examples in the learning module of different ways that pressure release weathering and the joints that form as a result of it can be expressed. Like some rocks undergo what they call exfoliation, where the joints are spaced pretty close together and they're parallel to the outcrop face or cliff face, and the rock kind of peels away from the outcrop. And the other type of, another kind of expression of the pressure release weathering is sheeting, where the rocks are fractured. And the fractures are spaced a few feet or like a meter apart or so, and the rock kind of splits into big slabs or sheets. All right, so those were the only two we went over for physical weathering. And the thing about the physical weathering processes that we've talked about is they'll form more surface area where the chemical weathering reactions can take place. Because all the chemical weathering reactions are going to take place on rock surfaces, and they're all going to be chemical reactions between minerals in the rock and water. Water's the main agent of chemical weathering. So we talked about the hydrolysis process. Okay, sounds like it involves water, right? Hydro. And our example reaction was a feldspar mineral. And there's a lot of feldspar in the world, as we saw in the igneous rocks. And acidic water really is the best for breaking down a mineral like feldspar. So we're going to say acidic water. And there's a lot of acidic water because carbon dioxide in the atmosphere will easily dissolve in raindrops, and the resulting rainwater is slightly acidic. Okay, and we want to remember what the process produces. The feldspar minerals are going to weather to form a new mineral as a result of this weathering, and it's going to be some kind of clay mineral. And then some of the chemicals that are in the feldspar are going to be dissolved in water. So we're let's just abbreviate it because I'm running out of space. DISS for dissolved chemicals. Let's say that, okay? Dissolved chemicals. How about dissolved chemicals? Right, we have to remember when we say dissolved chemicals, we're talking about things that are dissolved in the water and they're going to go wherever the water goes. So there are some mafic silicates that will also undergo hydrolysis and produce some type of clay mineral when they weather. All right, and our second chemical weathering reaction was a dissolution reaction. And this is distinguished from a hydrolysis reaction because we're going to see there's no solid clay mineral that forms, or any other kind of mineral. No solid secondary mineral, I meant to say. Okay, so our example was calcite, and we saw in the lab how the calcite mineral, calcium carbonate mineral, it will dissolve readily in even weakly acidic water. And we don't get any solid secondary mineral. We just get dissolved ions, and there'll be things like calcium ions and carbonate ions of different types. Okay, so we're just going to put dissolved chemicals over here. Everything goes into the water. Now, our third chemical weathering reaction was the oxidation reaction. It sounds like it involves oxygen, right? And it's usually oxygen that's dissolved in water. So there has to be a certain type of metal in the mineral in order for a mineral to participate in an oxidation reaction. And a good example are our mafic silicate minerals, because they contain the Fe2+ iron, and when they come into contact with oxygen and water, that's supposed to say oxygen. A little messy. Okay, it's going to form an iron oxide mineral like hematite, Fe2O3. Okay, and then some of the components of the mafic silicate will get dissolved in the water too. Okay, so these are our few examples of chemical weathering reactions. So practice with remembering what each of the processes involves, and what forms as a result of the process. Same thing for the physical weathering reactions.